No, I just had to. I guess the hub was overloaded or something. So go to.
Oh, are we live?
Yeah, we're live. We're totally live, and we just need to test the stream. Unfortunately, I do not get bars in here.
I do. Whatever, we'll roll with it.
And I just gotta log into the Wi-Fi. Super secret password. Was it 0318?
It's entirely possible to Google "Am I Game?" because we're so rapidly spelled "Am I Game?"
I don't know. If it's what is it?
1803.
1803.
Are we live?
That's exactly what I'm about to do.
Are we live?
Yeah, we're live.
People are listening to us wonder if we're live.
Yeah, people are listening to us wonder if we're live.
Where's the live?
It's right here.
Oh, people really are listening to us wonder if we're live.
And I probably need to update the stuff.
We have 26 subscribers. Agreeable shipment. I don't see it.
Let's see what.
I mean, like, I'm on our thing because you write at the top that we're live.
Yeah, February 2018. I haven't changed the title yet.
Streamed 1 month ago, 1 hour
Oh,
long.
it is? Oh, I'm on the live one.
How are you on the live one?
I don't know. I'm just trying to. I need to change the audio on this. I can't hear it.
Maybe I'm not.
Come on. Still trying to. I can't hear any audio for some reason. What?
Go on your machine. Literally, just bring it up on the machine.
And bring it up on the machine. And I could do that.
It's working. Let's tune the audio while we're here.
That's what I'm trying to do.
Alright, so see lab 22?
Yeah.
Hit the gears. Filters.
Yeah, it's just way too.
Yeah. Okay, so noise suppression?
Yeah.
Crank that up a bit. Do it to like 18. You're gonna make sure it still works.
Okay.
Gain?
Yeah.
So is the problem that it's too quiet or there's too much background?
Too quiet.
Okay, gain, increase that by a couple of volts.
Hello. Hello.
It's gonna take a minute. Also, we probably minus 1.6. Drag that input up, dude. It's gonna be unknown USB.
This one?
Yeah.
Alright.
Because we mute it sometimes. Leave that open, unchecked. Okay, output should be muted. You're good. Just let it.
What?
Just a quick brown fox jumped over to lazy whatever. Point. You're a feature presentation. You're a feature.
It's a little bit quiet.
Alright, go in and up the gain. Oh man, we had it subdued. See how it's still in the negatives? Keep going that way?
Yeah.
So we actually have the gain subtracting.
Yeah.
I would have put it to
Because
zero.
it was.
Do you have a Mac or Windows? You want to test it? Make sure it works? Sweet.
Alright, we're good.
You're good?
We're good.
Alright, just leave it on you.
How does the angle look?
Looks good, I think. Once he gets there, we can always tweak it.
Make sure it doesn't go to sleep.
Oh, it's perfect. Never mind. We're good. Alright. Especially when we're streaming. Oh, we're streaming.
I'm on that. Facing right now.
Yes. Are you all watching?
Good thing I shaved.
Don't worry.
With this out. With this.
That was the bigger thing in our old space. Sweet.
I walk with some thought. This one's pretty much empty.
Awesome.
It's going.
Oh no, you're good. You can hang back there for all that matters. We had John Skeet just like hid in the corner during the late game.
Here, get your left.
How am I supposed to get past here?
You're
supposed to. You're supposed to go around the other way.
around the outside. Around the outside. Is that really the lyric?
Yep.
Wow. Okay.
I thought it was Trailer Park Girls.
Two Trailer Park Girls.
I know we're gonna look up the lyrics.
Let's really not.
They sound.
It is Trailer Park Girls? Okay. The audience is always right, so. Here, I'm going to clip you. You've been clipped.
Alright.
You've been paused.
Is this
Wait.
is this just for recording or is this the
Just for recording.
all the amplification?
The application on this one is handheld, so it's a small room if you're from.
Do I have my spectacles? Yes, I do. And I guess I'll throw this over here.
It's like the second skill you pick up the speaker after not freaking out is project.
You from New York?
Yep.
Forget about it.
Okay. I'll pull me. Plug you. Welcome to our.
Yeah,
well,
thanks.
our-
Oh, I need a mini display of them, Depper.
I am not. But
I got
the
one in my
internet
bag.
doesn't know it's our March meeting.
Okay,
I always
thanks.
project. Project to the mic. Here, I'll just. Welcome to our March. Hold on, no. Well, welcome to our March meeting. Our feature present. Okay, this is
Awkward.
our feature presentation back there, but to fill the time for 10 minutes is Dave.
Oh, I got one. Hang on. Talk amongst yourselves.
The way they call that music curve when you have someone performing before the main act, I feel really weird.
He's your opener.
My opener.
Right.
It's awkward.
Real quick question before we get started. Last month, I think I mentioned we were going to screw around with the room and see what works. First month we didn't have any tables. Second month we had the weird sideways layout that made everybody have to turn. This month we're doing it like this, but of course as you can tell there's a USB table. So at the end, just see if this works better. If you came to all of these meetings, like at the end, I'm definitely going to ask for a preference so we know what to do moving forward. So just keep in mind. It is Epitech, capital E 1803.
We have we got a VGA here. Got a science fiction novel there. Power charger. Ah, here we go. What's this? No, it's not a VGA. I don't want that. Don't give me no VGA. I know. Give it to me, babe. Right there. Yeah. Thanks. Do 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 do. Da da da. Oh, everybody, evacuate the building in a single file.
For those who know what that is, that was a busy signal.
What are phones?
Oh, I don't have my name on this slide. Oh, weird. My name is Dave.
Microsoft Azure.
Yeah. Oh, well, I'll just tell you. My name is David. I used to be the president of Gang a long time ago, and I have I have a fan, and I have my retro Gang T-shirt here. This is pretty awesome. I don't think you can buy these anymore, and I am proud. I am excited and proud to be Joe's warm-up act. Thank you so much, Joe.
Thank you.
All right, just
Never had a warm back.
just stay there.
In the corner.
I'm going to talk about machine learning in Azure. Who's doing machine learning? Who's doing any kind of data science? You guys are making a pile of money, right? Machine learning's hot. People are who's getting email from recruiters about data science and machine learning? Put it on. Trust me. Put it on your LinkedIn profile. Your spam will go up exponentially. It's crazy. Data science is a big deal right now. It covers machine learning, predictive analysis, big data, artificial intelligence. All these things are really hot right now. They're taking off in large part because of the cloud. The cloud is empowering data science. The reason is because data science, these things like artificial intelligence, machine learning, they've been around a long time, but they take so much compute power that they're expensive to run, especially if you run your own data center. So if you run your own data center and you want to run something for some algorithm that's using deep learning toolkits or things like that, those things can run for days on a single processor. But tools have evolved to allow them to run, to solve problems in parallel. And so you can run, instead of running for 4 days on one instance, you can run for 1 day on 4 instances, and that helps a lot. It's not exactly linear like that. There's some overhead in parsing out this information, but still, you can get a lot more power by running these things in parallel. But there's a limit to how much you can actually buy and maintain your own data center, especially if your primary business isn't running a data center. Maybe it's doing the analysis itself. But with the cloud, you can actually rent that data center, and instead of running on 4 processors for 20 hours, let's run it on 80 processors, 4 hours. Just something like that. Let's beef this up and rent that power just for a short period of time and solve these problems in a short period of time, and then when we're done using them, we'll just turn this off and not pay for it anymore, because the idea of renting is you only pay for it while you're using it. And so this has kind of democratized the whole idea of data science. Things that used to be huge barriers to entry because you couldn't get into this. You couldn't use these tools unless you could invest in this massive amount of hardware. And now, me with no capital whatsoever, I can just go out and rent the hardware when I need it, shut it down when I'm not using it, and use that power. So this is probably the single biggest reason why all machine learning and big data and artificial intelligence and all this stuff, all this data science has exploded in recent years. It's really empowered many people to get into this industry. Would you guys agree with that? The guys that are actually doing data science, they're nodding vigorously. That's cool. Their mouths are full of jambalaya, so you can't actually say that. So here's the advantages that Azure adds. Actually, any cloud computing platform adds this. Is the ability to quickly scale your application out, to cluster servers together or instances of services together without doing a lot of configuration, a lot of hiring a network administrator to do that, and then that flexibility that you can say, all right, today I'm going to run just for a few hours, going to have 20 instances of this service running to solve this business problem. When I'm done, I'll just shut them down, and I don't have all that expense of maintaining a data center with controlled temperature and filtered air and replacing the parts when they break and patching the operating system when it needs it, blah, 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 blah. That's all somebody else's problem. That's Microsoft's problem. So within Azure, these are the tools that are available today to solve machine learning problems. I'm not going to list them here. I'm just going to go through them right here. It's just a lightning talk. First one is Spark, and Spark is part of the Hadoop open source toolkit, and it's available in Azure as part of HD Insight. Spark is a general purpose compute engine. So what it can do is really anything that you want to do in data science. If you want to write some Python code, do some deep learning, there's some templates in here that are available. Typically these things are written in Java and they're deployed as jar files to a Spark server, or I should say a Spark cluster, because when you create these things you can very quickly scale them out to multiple services in a cluster depending on how much power you want to give these things. And there's even though they're usually based on Java applications because they're deployed as a jar file, there's an SDK that you can plug into Visual Studio that allows you to write C# code that'll generate that jar file and deploy it to Azure and deploy it as a Spark file or a Spark service. These used to be available in as both Windows and Linux services, and because the Linux are so much more popular in Spark, Microsoft just dropped the Windows version. There's just Linux right now. So this cluster you can SSH into them and deploy your applications to them. There's a portal where you can manage and see what the jobs are running and how far along they are and how much resource they're using, so you can get an idea whether or not you need to scale out even more than you are right now. That's available for you just, in Azure. There's that big green plus new button. You hit plus and search for Spark, and then create a service by filling out things like the name of the service, how many machines are going to be in it, what's the password and the username, etc. All right, that's HD Insight Spark. The next thing is the Data Science Virtual Machine. Virtual machines are probably the single most flexible tool that's available inside of Azure. Once you create a virtual machine in Azure, it's yours. You can install whatever operating system you want on it. You can install whatever software you want on it. You can put whatever data or applications that you need to on it. Well, some of the virtual machines in Azure come pre-configured with software already installed. And if you're doing data science, this one right here, the Data Science Virtual Machine, is a good one to use because it comes pre-configured with a lot of the tools that data scientists want to use. For example, the TensorFlow, a deep learning framework, CNTK, which is Microsoft Deep Learning Framework, Jupyter Hubs, R Server, Python, Anaconda, a bunch of different databases. They're all just pre-configured on there. So spinning these things up allows you to start deploying your own custom solutions to Azure, and then you can cluster these as well if you want to create multiple ones, put them all in the same subnet, and run things in parallel, which is relatively, that part of things like TensorFlow are easier to do in parallel than they are just on a single machine. And it's your machine. You can remote desktop into it, or you can SSH into it, depending on whether it's a Windows or a Linux machine. In fact, there's a version for Windows and a version for Linux. This one I use a lot. I do a lot of talks on college campuses to computer science classes, and colleges right now are teaching a lot of deep learning and a lot of machine learning. A lot of them, I show them how to use the Data Science Virtual Machine, and they can use that for their homework or for whatever the professor is assigning to them. The next tool is ML Studio. ML Studio is a nice tool if you're just getting started in learning machine learning, figuring out how to use machine learning. It is a graphical interface where instead of writing a lot of code, which is typically how machine learning solutions are done, you can drag and drop shapes onto this design surface and set some properties. So for example, if you wanted to grab data out of a CSV file somewhere online, you can grab a data shape on there and just set where's the location of this file, what's the format of the file, and which columns are you interested in. Every machine learning solution has some data source, and so writing a lot of code over and over again is just plumbing code. It makes sense just to drop a shape on and set a property. That's code you don't have to write. Every machine learning solution has a part where you want to split your data into training versus testing data. There's a shape for doing that. There are shapes for common machine learning algorithms for doing. If you want to do clustering, for example, you can just drag a shape on there and set the properties of what you want to do. And best of all, once you've created this thing, you can click a button and it'll turn it into a web service. So you run these machine learning algorithms, it'll do your testing for you. If you don't like the results, you can, if the results don't come out the way you want them to, then you can tweak it until you get a good result, and then click a button and it'll deploy that as a web service. And the web service is hosted in Azure. So then your other applications or your partner's applications can then call that web service and do predictive analysis based on the machine learning that you've already done. Machine Learning Workbench is kind of the next evolution of ML Studio. This is actually a rich client application. It runs on your desktop, and it allows you to do test machine learning solutions locally, which is a lot cheaper and tends to be faster than running it in the cloud. So you can set up your machine learning solutions inside of the Workbench, test it probably with smaller data sets since you're only running on one instance, and once you have it working the way you want it to, then you can very quickly deploy it out to Azure, either through virtual machines or containers or to HD Insight Spark, and then get the scalability that Azure provides. Azure Notebooks are just Jupyter Notebooks deployed to Azure. Who here has used Jupyter Notebooks or is familiar with Jupyter Notebooks? Just a few of you are. So what I'll tell you, Jupyter Notebooks, what they are, here's a picture of one right here. They're essentially a combination of formatted text and executable code. Usually in Python, the Jupyter is spelled Jupy, which is Python, and they're really nice for if you wanted to present the results in real time. You want to say, here's an explanation of what I'm presenting. Here's the code, and run the code, and the results will be either graphically or in tabular format or whatever it is that this thing is going to do. Then you've got a documented, not only the report, but some explanation for it. Some people use it for unit testing or integration testing. If you want to have documentation of what your tests are running, and then the results of that test below it, that's kind of nice for that. They're easily distributable because they're all deployed online. And Azure Notebooks, which you can get to, right now they're free at this URL right here. I'm not sure how long that'll be true, but just go there and create a new set of Azure Notebooks, and it'll come with some sample notebooks. You can play around with them and learn how to use notebooks or how to program in Python or how to do machine learning, things like that. And then you can clone them or create brand new empty notebooks and create your own as you get better at it.
By the way, they're only free until you unplug the HDMI cable.
They're not free? That's not true. You're making that up. Finally, cognitive services are available. Cognitive services are a way for you to take advantage of machine learning without having to know anything about machine learning. It's just a set of web services that you can call. The machine learning has already been done to do things like analyze images, to do facial recognition, look at a picture of a bunch of people, find out exactly where the faces are, information about those faces, like are they happy, are they sad, are they angry, where are the eyes, are they male or female, are they wearing glasses, or do they have facial hair, how old are they? It'll analyze language so that you can do things like sentiment analysis. Is it generally a positive sentiment in the text or a negative sentiment in the text, or doing natural language processing. There's things for analyzing voices, doing voice recognition. There's things for analyzing, doing text to speech and speech to text, all sorts of things that require machine learning, but Microsoft has already done that machine learning for you. All you have to do is call a web service to make these things work. And usually the web service returns some JSON like this. There's a little example of it here. There's one service that recognizes celebrities. So this celebrity right here, who's that celebrity? Satya Nadella. That's right. That's my boss's boss's boss right there. So it'll, out of the box, it'll recognize that. There's also ways where you can upload pictures of people that you know that maybe aren't so famous as Satya, and it'll do recognition of them. You can train it with a few simple web service calls to train it to say, maybe recognize the people in your department or the people in your family, so that when you can use that for authentication, for example, when somebody tries to get into a door, maybe take a picture of them first and don't unlock the door unless they're recognized in this set of photographs that you've trained them on. All right, so this is, we're getting to the end here. These are the tools that I talked about: Spark, Data Science Virtual Machine, ML Studio, Workbench, Notebooks, and Cognitive Services. That's a lot of tools. And so, of course, the question that I always ask is, well, which one do I use? And, of course, the answer is? All of them. Is what? Not you. It depends. Of course, the answer is always, it depends. So there's no simple answer to that. There wouldn't be all this many tools if there was just one answer for all of them. But here's some of the factors that would go into when you want to do some machine learning. One is you may have an existing solution that you've deployed locally or deployed on some other platform. So for example, if you already got Jupyter Notebooks set up and you just want to deploy it to Azure, then Azure Notebooks is a really good example of that. Maybe you already have a TensorFlow solution, and then the Data Science Virtual Machine, which has TensorFlow built in. That might be the right solution for you. So migrating a solution that already has a technology that's available, one of these is one there. Migrating or working with a tool set that you already know. If you're already proficient in, say, CNTK toolkit, Data Science Virtual Machine might be the right solution for that. So things that take into account that. Of course, cost is always a factor. Some of these things are free, and some of them are really expensive. HD Insight Spark, for example, can be really expensive. You create a cluster of 8 machines, and you forget to shut it down when you're done, you may end up with a really high bill at the end of the month. And you may not need all that power, so that probably wouldn't be the right solution if you didn't need a ton of power. Maybe deploying something to notebooks would be. If you're doing something like TensorFlow or CNTK on the Data Science Virtual Machine, you can get inexpensive versions of those machines, but if you want to run them on a GPU, for example, that GPU hardware tends to be expensive, and you just want you to keep an eye on that. Whereas cognitive services, they have free versions of that, and even the paid ones are super cheap. They're like 10 calls for a penny. Notebooks is free right now. You need to balance that. How much power do you need versus how much do you want to pay? The required scale, some of these things are easier to scale than others. I would say the Spark is probably the easiest one to scale. Just simply set a configuration option and click OK. It'll automatically scale out or scale down. And then there's simplicity versus control. If you can find a solution that does everything you want it to do without writing any code, that's probably the right answer. So cognitive services is by far the simplest thing in here. And if there's a cognitive service that, if all you want to do is facial recognition, cognitive service is great. You just call it and you're done. But if you need to tweak that in some way, if you don't know exactly how, maybe you need to recognize people with hats or without hats or something like that that cognitive service doesn't do, then you need to move to something that gives you more control. And I think probably the virtual machines give you the most control, the Spark probably the next most control, and maybe the notebooks after that. So that's another balance that we needed to keep in mind as we decide which tools to use. And you're not limited to one tool. You can, for example, use the Workbench to develop a solution in Python and then later on deploy that to Azure containers. My name is David. Thank you so much for your time. Joe.
David's right, a lot of those can be expensive or easy to use. The cognitive services ones are super simple to use.
I'm a big fan. I actually did a talk here last year, I think, on cognitive services.
And you only want to use the facial one if you're okay with your feelings being hurt. You have your head a couple years or a couple of pounds, or even the wrong sex, so.
Thank you, sir.
For me.
Yeah, that's for you. Which one of those?
It's like, when's my first time?
Which one of those happened to you?
None. I've never tried it. I'm too afraid.
Here, so it doesn't go crazy. There we go. Got to connect to the network because I forgot to do that. So before I get started, doesn't even sound like microphones on, or is that for that?
That's on.
Before I get started, how many people prefer that you sit and watch me type code or rather me copy and paste code? I'm not typing. It was a rhetorical question. All right, I should probably close all of my work email and stuff.
All live. You switch back from your plan.
Yeah. Yes.
So appetite, yes. It's going to be capital E-P-I.
Doesn't get much better than this, tell you not now. Well, that's going. I'll talk for the first 3 slides, which are all the general fluff. My name's Joe Guadagno. I am a team leader at Quicken Loans. Some of you here probably have heard of that company. It's a small company downtown that doesn't really do much in the area. I've been a speaker for a little bit over a week now, so hopefully this goes well. Oh, it's one of those. Thank you. Sure it's one of those?
They got to connect to the Wi-Fi first.
Yeah. It didn't give me an option to connect.
I was just waiting.
Let's do this so no one watches me randomly type. There it goes. 1803. It's a good year. EPITEC 1803. Be sure nothing else is open. That's some hardcore networking. Okay, let's see. Who's looking for a job? Let's see. C#. What does he say? Data scientist? Oh, yeah, Java. Look at that. Taylor, Michigan. I don't even know where that is. Okay, so let's get started. So this is Introduction to ASP, and that's me, Joe Guadagno. You can reach me at jguadagno@hotmail.com. Heather, have a seat. Stay for a while. It's my Twitter handle. I tweet a lot, usually about random stuff around development, other things. Find out more about me, you can go to that short URL or just see me afterwards, and I'll give you the very long version of it. Essentially my first name, last name, .net. Again, I'm a team leader at Quicken Loans. I organize a conference in Arizona called Desert Code Camp, which gives away the second point. I'm from Arizona, not from Detroit, so this weather sucks. It was 85 degrees when I left home. It'll be 91 tomorrow. So I'm a Microsoft.NET MVP. All that means is Microsoft doesn't pay me, and I promote their products a lot, kind of like David, but he gets paid. What was that? Yeah, thank you. I'm a friend of Redgate, which means I talk about them, but more importantly, I'm a father to 2, husband to 1, most of the times, depending on whether or not she likes me. So for the agenda today, we're going to cover what's ASP.NET Core. This is not going to talk about, we're not going to go deep into code, just show a lot of what's new. We'll do a couple of code samples to explain it. This is more about the mechanics of how it works, what's different from ASP.NET Classic or ASP.NET Regular, however you want to call it. I'll cover some points of what's different between version 1 and version 2. There's some slight differences. As they get better, they remove things that you actually need to do. And then it randomly types by itself. Look at that. I'm not even doing anything. Hands-free. And then we're going to go back and we're going to talk about why it was built. And then we're going to cover all the new features or things that were released with .NET Core that aren't there. So the real reason why we're here, what is ASP.NET Core? The very long version of ASP.NET Core is essentially Microsoft realizing that the .NET framework, especially when it comes to ASP.NET, got too big, got too bloated, and it was very hard to make changes. And if you ever needed to distribute everything, you had to distribute system.web, which is over 10 meg or some ridiculous number like that now. So it was very bloated. And what they realized is that they were shipping so much stuff as part of the framework that they were opening up a lot of people and their customers to potential security flaws. So let's say in that system.web DLL, you have system.web forms in there, but you might not be using system web forms, but your site could be susceptible to any security vulnerabilities, memory issues, that kind of stuff, even though you're not using it. So they decided to do is figure out the entire framework, what's needed, how they want it to work, and start breaking it down into little pieces. So the way I like to think of it, the new trend in development now is microservices. ASP.NET is a series of microservices. Each individual packet, everything's NuGetted, where you opt into what you actually want. So if you're not going to use web forms, you don't include web forms. You're not going to use MVC, you don't include MVC. If you just want straight bare bones serving up a file, you can do that with a couple of lines of code. So everything in this is opt-in. They don't give you the kitchen sink and then you have to go delete stuff. So, if you start a new project, which most of us never get to do, if you do file new MVC project, it's 50 files that get created, a bunch of NuGet packages. File new in here gives you like 4 files. You get a little bit more than that, but in essence, it's 4 files. So, why build with ASP.NET Core? for a lot of people, like I was talking to David on the way here, it's a little bit different. It's a different mindset. The code and everything else is the same, but now you're opting in for everything. So you really got to think about what you want and what you need as part of what you're doing. The second thing is it's super fast. They made it so much faster. They release benchmarks after every major release. They do them in previews, but the previews don't count as much because there's debug stuff in there. But you know, they were trying to hit the likes of Node and Java and make sure that they are the fastest on Iron. Another reason for this is ASP.NET Core runs on multiple platforms now. You're no longer tied to ISS. You're no longer tied to Windows. If you want to launch up a couple of containers or a couple Linux instances, ASP.NET Core runs on that. ASP.NET Core also runs on Macs now. They run on most flavors of Unix. They run on Macs, and they run on Windows devices, which is a great thing. So at least that openness with everything. This is the why. So this slide violates almost every rule of presentations. You never want more than 1 or 2 lines on there, because right now everyone's just reading that and no one's paying attention to me. So right now I can make funny faces and no one's going to know. Essentially, this will be available. If you go to my site, you can read the why, but I pretty much explained it to you. So these are the 3 biggest things that I see that are built in now. So it's integrated natively now with a lot of common frameworks. So you get Bootstrap in there, you get jQuery if you want, you get the most common dependency injection frameworks, which I'll cover a little bit. And it's cloud ready for environment as far as configuration is concerned, with I can show you. Plus, there's a whole brand new configuration system that lets you pull in configurations from anywhere. It could be a cloud, it can be a database, it can be an INI file if you're a glutton for punishment. It can be a JSON file, it can be an XML, it can be pretty much anything. And we'll show two different variations of it. But like I said, the built-in dependency injection, which we'll cover towards the end, is probably the biggest feature. So enough of me talking, we're gonna go build an app. So let's go and stop you for now. Okay, we're gonna go to everyone's favorite development environment, the command prompt. This is, I think, really the reason why they did it, to try and get all these Mac developers, because they love being in terminal, love being in black and white consoles. That's not the real reason, but it always sounds fun. I used to have a Mac until about a couple months ago. So let's just increase this font a little bit for everyone so we can see it. Hopefully that's readable. So everything now is done on the command line. If you're using Visual Studio, you can do File, New, and this, but I'm going to show you the guts that pretty much happens behind the scenes. So you do .NET New, and a whole bunch of stuff comes up. These are all the templates that I have installed on my machine. So if you think in Visual Studio, File, New, ASP.NET Core, you'll get these in a prettier, icon base. So on the screen, you'll see a couple different things. These are the template names. These are the short names for which we're going to type. This shows you the languages that are available. And this shows you common tags, which is a searchable way of doing things, in case the event we start having more and more and more templates in here. So if I look just before the templates, you'll see a bunch of commands that happen. Help, list, name, output, blah, blah, blah. I'm not really going to do any of them. We're just going to do .NET New, and then we'll do empty, which is web. So this will just get to show you the minimum that you need. So let's create a directory called Hello World Empty, because this is the empty solution. And by empty, they mean it might have like 15 or 20 files. It's not totally empty, but it's stripped of most of the typical fluff that's in there. So I'm going to do .NET New, and then we are going. You can optionally call it something if you want. I'm just going to say build me a new web, which is the ASP.NET Core empty. If I put -name in, it'll create all my basic namespaces. By default, it will just use the directory name. So all the namespaces in this app are going to be Hello World Empty. So when I do that, depending on the Wi-Fi, it's going to take a minute or so. It's going to download the template. It always downloads the latest template. Then it does a .NET Restore, which goes to the NuGet packages and downloads all the NuGet packages. So let's take a quick look at what that looks like. So I'm going to use Visual Studio Code because it's lightweight, faster, and it's easier to show things. You see this empty project. Let's zoom in a little bit more. Is that too big for the guys and ladies in the back, or is that good? Okay. So bin and OBJ folders are normally what we have, but you'll notice here now we have a www root directory. This has everything for your application. Ignore this screen for a second. You notice it's totally empty. There's nothing in there. No controllers, no default ASPX files, no HTML, nothing. We're going to create whatever we want. And then you'll notice also that there's a lot of gobbledygook gone from here. Let's just do this now. It's going to add a bunch of stuff to the project, mostly for building. This is the entire project file. So it tells you what version of the SDK we're using. It's just system.web pretty much. What is our target framework? You can do .NET Core App 1.0, 1.1, 2.0, any one of the framework versions, and you can just manually change it. We're telling it what directories to include in it, in this particular case saying everything in www root we care about. And then remember I said before where we wanted to get rid of the system.web namespace because it was gigantic? Well, they kind of did get rid of it, but they replaced it with Microsoft ASP.NET Core.all, which includes everything. But it actually doesn't include anything. It references everything. So when you actually build your product, it'll just take the NuGet packages that you need or the individual packages and build them as part of your suite. So if when you deploy, you won't actually see Microsoft.ASP.NET Core.all, you'll see whatever packages we're using. And then that's it. That's our whole CS proj. The program file is just like a console application. It goes and tells you how to start the application. In this case, we're calling a method called build web host. We're passing a set of arguments. The arguments are what's coming in from the main. So this technically compiles a console application or an exe that you can run and pass command lines to. So if you think about this, you can actually just deploy an ASP.NET web app on a USB stick, put it in, run the actual application, and up comes a web service. You can start, building kiosk type applications, or just copy and paste it onto your machine and run it. It has a built-in web server now called Kestrel that does pretty much everything ISS does, just not as much. So in here, we're not going to talk about this much, but essentially we're doing what's called a web host create bind. This essentially says, okay, for web host, this is how I want to construct the application. So this is where you tell it what to do. And we're going to tell it what to do by using what's called the startup. So this startup tells us, okay, here, web host, do this. So think about that if you did VB, your submain. In C# you have main, or you're pointing to whatever your default .index is. This says run everything that's in startup. That will tell you how to start my app. And then build. The build will compile that all and then actually run it. So let's take a look at the bare minimum startup. Let's just make this full screen and we'll hide that. So the first thing that we do is called configure services, and we're going to cover services in a minute. That essentially tells us, or tells ISS, Kestrel, .NET, whatever you want to call it, what services you're actually using. Are you using directory services? Are you using any databases? That kind of stuff. And then we're going to go and configure the app. And you'll notice when we're configuring the app, if I don't hit the right click button, we get two parameters passed into us. The app, which is the application we're actually trying to build, and the environment. The environment is very important in this case. Built into ASP.NET Core is the concept of environments now, because no one, or hopefully no one, just publishes from their app to their prod environment or their regular environment. So it has the concept built in of environments, and it has some built-in environments like development, staging, and production. which is why you see right here a little token on line 23. If environment.isDevelopment, so if this is my development environment, then I want the application to use developer exception page. So this is the old yellow screen of death. Now it's a white and blue screen of death instead of yellow. They tried to change the monikers. So it's going to be called, because it's white, blue screen of death. There's that YBOY. It's just complicated. But you'll notice that you can do things based on environment. You can also, as a side effect, the ASP.NET framework or Microsoft Build in here will actually recognize environments in names. So if I have configure, it's going to run that all the time. But you can actually have a method called configure development, and it will actually run this particular code if you're in development. You can do configure production too. So if you want both sets instead of having a bunch of if-then statements, or if you want to write unit tests for these individual items, which I strongly recommend you do, you can separate them out there instead of having a if is development, if is staging, blah, blah, blah. We'll also talk about later on how you can change the your app settings automatically. There's no reason, there's no need for web transform configs or to manually, copy and paste the config and change the names or rename them anymore. Okie dokie. So if I go and run this, let's do hello world my gang. So if I hit run, which is just F5, up is going to spin up the Kestrel web service, which will pretty much just start a local copy of Kestrel, which is a version of ISS on my machine, and execute it. If I hit F5, it will start a copy of, guess it didn't like the original F5. So you see what it did right there. It actually, if I look at the output, ignore that, but you see hello my gang quickly. It went and started right away putting a whole bunch of yellow text in there. That's mostly because we're in debug mode. I went too fast. Essentially what it does is it goes out and builds it does a NuGet restore right away, loads everything onto the machine to make sure you have what's version there. Since it was the first time I ran it, the packages were not available on my machine, so it looked at my CS proj and then pulled down that system.asp.NET core all and then ran it. Super exciting stuff, right? Because that's the end of my demos. Okay, so now we're going to go into actually how we go about using it a little bit more. So if we go back and look at our startup here, this. It's really hard when you're working in Zoom because right now on my screen, every letter is like this big. If we go and look at this, right now we're saying on the app.run, I want you to asynchronously, with this given context, await and run this. So essentially we're writing out asynchronously to the response hello world / my gang. So any web request that comes in, that's all we're going to do. That's kind of boring because we don't always just do that. So let's take a look at how a lot of that works. So we're going to go back to PowerPoint for a minute and start from here. And talk about some of the services that are available. We're going to cover logging in a little bit, but you get the hosting environment. That's the ENV that we started in there. That tells us what environment we're in. You also get a default logging factory. They created a common interface for all logging, and it matches whether you use nlog, log4net, all the others. The providers will adapt to this framework. Anyone that's .NET Core compatible, you can use. So you don't have to bother wiring it up or anything anymore. You just include a copy of the package in your CS proj file, which we'll do at the end, and do it. Configure services, we're going to touch on that a little bit, but not too much since we don't have a great deal of time. But in the configure, we can set the application builder. Again, the hosting environment, we can override it. I'm not going to cover how you set it. There's a blog post on MSDN that tells you how you can change it. There are several different ways you can have an environment variable. You can change it in your configuration. You can change it via PowerShell. You can change it by a setting in ISS that says this is prod. So when .NET Core starts up, it knows what environment it's in. Which means technically you can deploy all three configurations, which I strongly suggest you don't, to any environment, and .NET will figure out which one it should load. So let's talk about middleware. So ASP.NET is all about middleware now. So everything that runs in there is what they classify as middleware. So if you think about it this way, you have the browser, ASP, middleware, your business logic. That's what kind of gets displayed back to the browser. So you get a request that comes in, ISS says, or Kestrel says, okay, this is the request. Who wants to handle it? And you actually have to tell it who handles or what handles what request. So it goes from the first one. It says, okay, first one, and this is based on the order code, which we'll see in a minute. Okay, here's the request. It could be URL index.html. Do you know how to handle that? Nope. Okay. What's the next one? Do you know how to handle that? What? Nope. What's the next one? Do you know how to handle it? And it just keeps going down the line until it finds who knows how to handle it and then comes right back up. So once number 3 says, hey, I know how to do that, it's going to send the response back to 2. 2 is going to send the response back to 1. And then ultimately the response gets back. A lot of people might say that sounds like a lot of busy work for just finding out who's going to do it. Yes, it is kind of, but that's what ISS has been doing for so long. There's a lot of people don't see it, but behind the scenes, there's a bunch of handlers that tell it what to do, and you set the order. It's just usually set by your server administrator in most cases, or the web config. There's a whole bunch of built-in middleware providers. Authentication comes out of box. All these things come out of the box by just referencing system.asp.NET Core.all. Response caching, which we'll see. Response compression, we're not going to see. Routing, you'll see there's built-in routing. We're going to see that when we do the MVC demo. Session handling, we're not going to cover. If you've done any ASP.NET development before, it's pretty much the same. Static files, we're going to see. And URL rewriting, we're not going to see. So we're just going to cover that. Again, it's mostly just for reference. So let's go back and look at how we can go and build a separate set of mappings. So I'm going to go to my secret project that has all the code pre-done. And we're just going to copy out a bunch of code, and then I'll walk you through it. We've seen that one, so let's go here. So let's paste this right about here. So we go and look at this code. Did I paste in the wrong spot? There's the problem when you're so zoomed in you can't see what method I'm in. There it goes. Miss it again. Come on. Yeah, right there. Should be right there, right? Yeah, there it goes. Okay. Thank you. So right now we added 3 different methods in here for handling what we're calling a map. So if we get something that says map tests if we get something that says map, we're going to redirect to this. So let's take a look at how we do that. We're going to create our own separate context that tells us when to do it. So let's copy out this part. And like we had this app run, if nothing else calls us, we're just going to default to hello world. Let's change that a little bit. Now I'm adding a map and saying anytime you see a URL that ends in /map1, I want you to run this chunk of code. If it says /map2, I want you to run this chunk of code. If the event it doesn't hit map1 or map2, your default is this. Because remember, you go back to the original diagram. Hey, can you handle it? No. Can you handle it? No. Can you handle it? No. And it keeps going down the pipeline until there's nothing more. If we didn't have this here, which is a default, we would just get a blank page. It doesn't know what to do with it. So let's see what map1 and map2 does. Pretty much all we are is just writing out to the browser map1 and map2. So let's start that again. And it crashed. Why did it crash? Now I'm zooming out so I can read everything. What are they complaining about? That's a lot of stuff. I think I missed something in the startup. Stop it so I can actually. Let's run it. Yep, that's probably the case. So let's format this. I don't see an extra curly brace. Well, the good thing is I have the code backed up so we can show it. Essentially, it's going to go through. If I contain and do /map1, we'll see that code or /map2. And then for sake of time, I am not going to go through and debug it on the fly. Oh, man. It's lovely when you run it like 300 times at home and it works fine, and then you get in and it fails. Oh, I know why, because I've configured twice. I was supposed to do that. Sorry about this. This code here was supposed to be here. And then this doesn't exist anymore. Sorry. And I got an extra curly brace. Now I can run it. Sorry about that.
Shortcut format is Shift-Alt-F.
Well, let's skip over that part of the demo since it failed miserably. One more time. That's it. You go bye-bye. we'll start showing you the real way of doing it. So I'm going to go and create a new app in that same directory and go through the more meaningful, because in most cases you're not going to create your own folder structure to see anything. So for this one, I'm going to go through and copy a couple of files over to try and show you what I mean by how you build up your request pipeline. So bear with me for a second. I go here, here. So just to show you what I copied 3 files in the My Files directory that we're going to serve up. And then inside of the www root, I created a simple index.html page, which should show this. So if we start out and run, someone have a question? So if we start out with this app and run it, it's going to give me a second, and it's going to want to add all the debugging stuff to it. If you don't do that yes step, it prompts you for what environment do you think it's going to be. You can do .NET Core, and it adds everything to start it. So let's do start debugging, and we should get our hello world that we had before once it completes the build. Okay, so we got our hello world. If I go here, thank you, I finally got a demo working. If I go localhost, and if we look here, I had a file called index.html. If I type in index.html, nothing gets served up because it doesn't understand how to serve up that file yet. The only thing it understands is how to run and say the words hello world. So let's go and add that in there. So I'm going to go and do an app.use. I probably have to zoom in again. App.use, and I'm going to choose static files or user static files. So once I do that, I tell ASP.NET that I want you to serve up static files. So what it's going to do is, based on the URL I put in, it's going to look in the file folder that's on the www root and determine whether or not that file exists. If that file exists, it'll serve it up. If not, it'll just serve up a 404. So let's restart this. And it's done. So now if I do www/index, hit enter, and I got hello world. Anyone want to fathom a guess as to why I got hello world? Who said that? Yep, it's the order. Remember I said it tries the first one, goes, tries the next one. Since that first one is just a run, it's going to execute that code and never get to the use static files. So in order to get that to run, you have to come up here and do this. So if I restart the application now, I'll see by going to that www/index, I will get it. So if I come back here and hit refresh, I get that blank static page. So again, I opted into static files. But now I come here and I want to see a picture of my daughter since I've been away for 3 days. This is not what she looks like anymore, but this is my wife's favorite picture of her for some reason. She's now 18 and a beast. So in order to do that, we have to tell it that we want to be able to serve up files from that directory, because I can't simply just go here and do /myfile/Emily. It's going to show hello world because it doesn't know anything about that. JPEG's not a static file, it's an image, so we have to tell it how to handle that. So for that, hopefully this copy paste works a hell of a lot better than the last one did. So for that, we are going to, see a little note here. If you can see it, in the previous versions of ASP.NET, before they made that .all package, you actually had to reference static files separately, but now they decided, put everything in there and we'll take out whatever you don't need. So I am going to put this one up above the static files. In this particular case, as long as it's above the run, it should work because the static files aren't JPEGs. So if we look here, we're telling it to use static files. In order to we're telling it to use a different directory within static files. So for this one, we have to pass it in a set of static file options. So this tells us, other than HTML files, what else do you want to serve and where do you want to serve them? Let's do Control P and get the system.io in there. So we have to physically tell it what directory we want it to come from. So we say here, create a new list of static file options. For the file provider, use the physical file provider. You can actually use, if you have a database provider where you want to serve up your images from, let's say, blob storage, you can do that too. You can pull them in from blob storage and generate them on the fly, or if you generate your images on the fly, you can change the provider. This one is just a plain, look at the physical location on the server and serve this up. So we're saying, get me the current directory, anything that says the current directory and the subfolder my files. So now we got www.root/myfiles. Anything in there we can serve up. And then you only want to do that when the request path says my files. So the files don't have to actually match. I can call this my pictures, even though the folder underneath is my files. ASP will say, okay, let's translate those. But for simplicity, we'll just do my files. So if I redo this, by the end of this demo, I'll have like 90 tabs open because I always forget to close them. So if I do this, now I'll show up a picture of my daughter again. And I can do that for my son, who I believe was JJ. That was his modeling picture. He used to be a model when he was a kid until he decided to walk, and he was walking with a bottle in his mouth like this, just drinking it, not holding it, and he fell down and landed just like that, and his bottom tooth came right through his lip. We had to peel his lip off of his gums, and that ruined his modeling career. No one wants a kid with a scar at 18 months old. So, but anyway, enough of the tragedy. This doesn't mean, however, that I can just do that. Again, it says to serve static files from that directory, but it doesn't know how to handle my files. Now in ASP.NET, you had something called the directory browser, which you can enable or disable within your web config or a site. Remember, I said everything in ASP.NET Core is an opt-in system, so we have to go back and tell it that we want to do that. So if you could imagine, it's something on the app. So we can go to app dot, and then you see, I didn't show this before, but there's a whole bunch of uses. So they built in a lot of different things for you to do. I am going to use Directory Browser. And then even for this, you can override it, pass it a new file provider, and say you can only browse this directory or that directory, which is what I'm actually going to do. To be safe, you want to do it. Oh, I didn't do that. To be safe, you'd want to do it for a specific directory, but right now we're just going to do it for this. So I hit restart. Let's go back to the 19 tab that Chrome is going to have open now. And now it has it showing everything. So if someone just comes in, it's the first thing that they see, which is why I say you typically just want to show it for a particular directory. Right now it's going to show the base of the www root directory. You notice the My Files is not in the www root directory, so it's not showing it. But if I do My Files like this, if I do My Files like this, it should show me the money. It should show me the list of files, but it's probably because I didn't add in the actual directory. It only allowed directory browsing on the first because I didn't do a new file provider, which will save you time and not type it. Another thing we can actually do here is add in content control. So you can do expire headers or set caching of files programmatically through the code. So if we come into our code snippets, we are going to add this extra parameter on top of our file provider, which says, essentially on prepare response, we are going to add a headers to anyone that accesses a file in this directory to keep them for a max age of, I think that's 600 seconds. So for 5 minutes, don't reserve up this file, just cache it on the browser. So if I restart this and run it in Chrome, I will warn you now, when I ran this demo earlier today, it broke. I think I have a bad version of the Chrome developer tools, but we're going to try it anyway. I've already failed once. What the hell is the second time now? Let's go to the developer tools. And if we go and look at the network spot, if I hit refresh, I got the image, and I'm going to do it one more time just to see. You'll notice I got a 304, which is not modified because it was originally cached in, and that's probably really hard to see. So 304, which means it's not modified, so it didn't return it. And if I just hit refresh again, you know, it's a 304, and we can keep doing this for 5 minutes, so ultimately it returns back again, but we don't need to do that. You can also do use file server, and that will act as a file share, so people can just do any file that's in a given directory. Directory browser will just show it. File server will just actually allow anyone to hit any folder, and it will just look at the code. It will look at your folder structure and see if it can come up. So we're going to leave this app for a little bit. We're going to go and create a new MVC app just to talk about exceptions. Do you guys typically stop and take breaks, or do I go all the way through? Okay. Nah, I'm a marathon horse. I've talked for at least 15 minutes in a row once, so I can do it. So we're going to create a MVC app. So let's make a directory. The one thing I really wish you would do is just create. So when you use Ionic or most other command line tools, you do a create, and it'll create a folder there for you and do it, but not this. So we have to tell it, hello.net, what to do. So we're going to do a .NET new, and then call this one MVC. And then, if anyone uses code, this is actually, you can do this in the path, code dot, and turn it on. There's also an add-on. If you do Control-Shift-P, you can do, I think it's, just type in directory and it'll give you the setting to allow you to be able to do this. It essentially adds code to the environment path. Let's go see this one. So this one looks a little different. Obviously, it's an ASP.NET MVC application. I have my typical models directory, typical controllers, and vice versa, the order I touch them, and views. One of the things you'll also notice is that in this app, there is a app settings development and an app settings JSON right here. You can ignore the bundle one. We're not going to really talk about that. But this one allows you to have separate settings for development and separate settings for production, but we're going to cover that in a little bit. So now we're going to introduce just some errors to show you the error handling that happens. So I am going to take a code from our lovely code book. This is the directory browser code we should have used that shows you just to allow directory browsing in that. So let's go and copy this code and replace the view. So this is in no way, shape, or form any way you should ever write an index controller. Essentially, I'm looking for a parameter to just throw an exception because we're going to use this demo a couple of times. I don't want to have to keep, commenting and uncommenting code. So if I go and run this app, I have to make sure the other ones stop. This is another thing to note. So right now, this application is still running. I haven't stopped it. And I want to show you what happens in the event you run another app. Right now, by default, ASP.NET Core, when you're using code, uses the same port for any app. So they always default at port 5000. So if you run it, the message you get is not super clear. So just showing you once, and then you'll see it, which should automatically trigger that, oh, I forgot to stop the other one. In the event you have two of them open, maybe it's just when you build presentations, but essentially it's going to tell you that there are no ports available for it right here. It says the address is in use. So once you see that, that should be a clue to go here and see the one with the yellow bar or amber bar and stop it, and then come back to the other one. So this is the out-of-the-box ASP.NET Hello World MVC app. Gives you a bunch of stuff, mostly, sorry David, to sell you on using Visual Studio and Azure and other things. But the good thing about it is if you're just getting started, there's a lot of how-tos down here to get you started on building out a lot of this. And a lot of basic overviews of just general stuff. So if you just do .NET New MVC, there's a lot to help you get started. So we're going to go and modify. We modified the index page to show an error. So I'm going to do / I think it was throw error. What did I call it? Index throw. Throw equals true. And when I do it, because I'm in debug, I get this new experience, which is all red, shows me the chunk of code I'm doing. If I hit play, I'll get the, if I hit play, I'll eventually, I think I broke it again. Oh, I gotta hit this play, sorry. That's the start play, not the continue play. I'll get back and I'll get the blue and white screen of death, or I like to call this the Azure screen of death because that's the colors of everything. This one's very similar to the previous one. Tells you everything that happens. You can see the query line, any cookies, any headers that were passed. So one of the reasons why I bring this up is not so much to see this. In version 1.x of the .NET Core framework, Microsoft treated every app that you built production to start, which means this screen was never enabled. Now, by default, everything is treated as a development environment first. So when you play on your local machine or hit debug on your local machine, you'll get this expression. But if you started with 1.1 or if you're still using 1.1, that's not the case. But you can easily change it in your environment if you need to, if you want to see what production is. Okay. Another thing we're going to look at is status codes. So let's go back. I'm going to stop this for a second. Let's go back, and by default, ASP does not return any status codes, or it returns a status code, but not in any meaningful format by default. You have to opt in to use it. So if I go here, actually, let me restart it. If I go here and decide to try and go to a page that doesn't exist, you just get a page not found. You can actually have it return physical status codes by opting into that like you do everything else. So we're going to go to startup, and in our configure, you notice here in the services we told it to add MVC now. We are going to tell it to app.use status code pages. And this allows you to create custom status codes. So you can create your own 404, 30, or 401, 403, 500, 501. All those you can create yourself. If you don't create one but have this enabled, you're going to get a super generic one, which, as you could probably imagine, if I go and do this, you're just going to get a status code 404 because I didn't put anything to the page. You can actually change it to tell it to show something on a particular page. And I'm not going to put this code in here, but just to show you. Actually, I will put the code in here because I didn't have it here. You can do app.use status code pages with redirects or re-execute. So you can say if you get a 303 or something, or sorry, a 404, redirect them to another page. Or in the actual static code pages, if we navigate through here, there are 4 different overloads that can tell you, okay, for these codes go here, for these codes go here. So it's super configurable as to which way you want to go. So let's talk about the configuration. So this is a PowerPoint for just reference to show you the different types of app configurations you can do. So out of the box, these are the 5 that are supported. Little Birdie told me that this is going to change in a little bit. There's a project that's on GitHub where the ASP.NET Core team is working, where they're adding a generic type interface to configuration that will allow you to use virtually any type of configuration provider you want. You can opt in. It's like almost the old way of creating ADO.NET provider. They're providing a framework where you can have your own. So if you have a place like we do at work where we store our configuration similar to Azure Key Vault, we can write a provider to go there to get the configuration so no one actually sees it in code. So these are the ways you can do it. You can do it via environment variables, command line arguments, in-memory.NET objects, which I'll show a little bit, Azure Key Vault, so you can actually add that provider and it will go to Azure Key Vault to go and get any of the credentials you need. Keep in mind that assumes that you're connected, which your website should be connected anyway. So let's go and do that. I'm going to go back to my handy dandy list of code, and we are going to create a new JSON settings file and add this to it. So since we're in the development environment, we're going to go here. I'm going to add something called app settings. And you can call this whatever you want. App settings is just the typical name for it. And I put one too many parentheses in there. So for this one, we're going to create it. We're going to have an object that's going to say city property and then the app name. And then we're going to take that and turn it into how to actually use it. So let's go back here to our development, save this. And for sake of brevity right now, I'm just going to replace all these with a configuration item. So let's go back to our code snippets. Oh, I don't have that as a code snippet. That stinks. Sorry, now I'm going to have to type. So we're going to do let's copy it from the other because you've already seen me fail typing twice now. So I'm just going to take this, put it in the MVC app just to show you what it looks like. Let's do an app run here. So here we're going to tell it to just outline the city. So I'm going to do bracket in here. And do configuration dot parenthesis, oops. The IntelliSense with this part doesn't work as easy when you're doing it in the shortcut syntax. So do city. There it goes. I don't think I need to do app settings because that's the default for it. But I've been wrong before, just ask my wife. Did I run the wrong project? Oh, maybe it is app settings. Oh. No, I actually didn't tell it to load the configuration file. Sorry. So I have to go to here. And do this part. So in the startup, I have to tell it how to load the configuration file. So let's go here. So here we're telling it where to get we're creating what's called a configuration builder, telling it what directory to go from. Right now it's the content path, which is everything in the root of this folder, not in the www root. We're telling it, look at these different JSON files. So the first, actually I probably shouldn't do that. The first one, take is app settings. You can call it anything you want. It's totally optional and you should reload on it changing. So in the event I go and change the file, it'll reload and refresh. Also add any other app settings that match the environment host name. So look for an app settings, in this case, .development.json. Tell it it's optional. We're going to add environment variables because we're going to look in the environment also to see if there's any configuration items. And then we are going to build it. And why are we not seeing it? Don't take it while there's a squiggly line underneath it. I had it set. Why didn't I? Oh, this has to go in the startup. not configure. It's the hardest part for me when I first started with this, as you can still tell, it's a struggle at times, is remembering which sections all these things belong in. So here I need to create the I in hosting environment, env, and then with dependency injection, it will go and throw that in. Now I have access to configuration. Now this will work. So if I haven't already confused you, let's go over this again. So in the app startup, we're doing what's called configuration building. So we're taking the configuration, ASP.NET Core is bringing us in. We're telling it to start off at the base path. So everything in the content root, which is everything here down. You say, okay, we're going to use a JSON file for configuration. Its name should be appsettings.json. It's optional and reload on true. So that means if anytime it changes, the application is going to restart. If you have this optional to false and that file doesn't exist, it's going to blow up. We're also going to add another JSON based on the environment name. So the first one it's going to look for is appsettings.json, which in most cases should be your prod. Then it's going to look at appsettings.yourenvironmentname.json, and then it's going to add the environment variable. So it's going to go app settings first, app settings.development second, and then look in your environment third. Yeah.
I'm just curious why in the case of the app settings.development.json you don't have the reload unchanged.
I didn't put that in there.
Okay.
That's just,
I thought maybe just not reason.
nope. It's just I got lazy.
Yeah.
So why optional? Why should you config the optional?
So for this particular one, you might say if the file is present, do it. If not, whenever you're ready. You would set it in case you don't want to do that. So in most environments, you would actually want to build it on the server for a lot of the environment variables. You wouldn't choose it. You'd set it to be optional if you're not expecting it. So like a thing like if you have a fixed name like client.json where you have client specific stuff, but you don't need to load anything from it and you don't care if it doesn't exist. For your main app settings, you'd never really want it optional unless you're just going to override based on some defaults. So now if I run this, which I believe I already did, I come here and refresh. Maybe I didn't rerun it. Ha! Why you no work? I swear these all worked this morning when I tried. Apparently I didn't pray hard enough to demo gods. Unless I typed the name wrong. Oh, I know why. I think I know why. No, I don't know why.
Is it how it's being referenced?
That shouldn't be it. I'll just go to the backup and pull it up just to make sure. Okay. Oh. I did it in the wrong demo. Okay, let's go look how to do it in the MVC app. That one works. So we're going to come here and add a similar thing, but we're going to add it as a separate file. So say you don't want to do JSON, but let's say you want to strongly type class that you can use throughout your app. So we're going to create a configuration file with the same name and city in it, and then we're going to use dependency injection to pass it to our views for us to be able to get to it. So let's go to the hello.net, which should be this one. And let's start off with a going to create a class here called app settings, which I have a simple public class with the city and name on it. Then we are going to go to the startup and add in the configuration. And now we're adding these two new items that we haven't seen before. This says we're going to configure a app settings class or app settings type, and we're going to use it from the section called app settings. So it's going to go out, get the app settings that we just created, and create a strongly typed class out of it. So if we looked at our settings here, you'll see I have the app settings name and city. We're going to convert that into a class that we can use. And let's hope this time it works. So that's what that does. And this says, okay, make this a injectable item. By transient means only create a copy of it when it's needed. We're not going to create a singleton for it. Anytime it's referenced or passed into a class, we would then load that file and use it. There's a couple of different options. For this demo, we'll just use transient. Now we're going to go and reference it in a view. So we're going to make it available to the shared view in the layout. We are going to reference this here and take in from the class app settings, we're going to get the value of the city. So we make that available by adding it to the underscore view start imports. So these two lines here allow me to be able to inject it. So first I say use extensions options, which pulls in the configuration, and then we're going to inject into this view, or pretty much into all views, the ability to see the application settings. So if I go back and look at my layout, I'll see in the title I am showing the application settings, and if I do this I should get IntelliSense with city or name, and then I am going to change the home section. So if we look at the page again, where is it? This one. We're changing this title and this name here. And I am just referencing again the app settings.value.name. And that's because I was able to inject it here with everything else. So when I hit play, we'll wait. And my title should change to the city, which it's really hard to see, but it says, let's zoom in. Ah, of course. Stop it. Hello World, Southfield, and then down here, the actual name has it -dev. Now I can go in, because I believe I have live reload turned on these, I can go and change this to, let's say, not development. Let's do .mygang. No, actually, let's not do that one because that one's harder to see. Actually, no, that one's easier to see. Let's do mygang, and then if I hit save, I didn't turn on that, but if I refresh, now we'll see, just to prove I'm not lying this time. Hello, .NET Core mygang. Yeah, it actually worked, right? One demo worked. We can go and change this to prod to use the settings in here via many different ways, like I said, but for now we're not going to cover it. Essentially, you would just add it to your environment variable, and it'll read this in as a prod. So now we're going to go kick in and add some logging to this app just to show how easy it is. Oh, at least it was easy when I did the first demos. Who sees now? So do that. I'm just going to show you a quick list of all the log providers that ASP.NET supports, or the different levels. So there is a new level added that was not in most versions. So you have trace, which is default, which logs everything. Then you go debug, information, warning, error, critical. Now all these have a method on there, so there'll be a log trace, log debug, and so on. And in my notes, it kind of tells you what the levels are. Each organization treats these slightly different than the others, so I'm not going to really cover each of them. As far as providers, there are 6 of them out of the box: console, debug, event source, event log, trace source, and Azure App Service. So the Azure App Service allows you to log to that log. There's also some other ones that you can download. You can get an nlog, there's Log4Net, there's Application Insights Logger, and there's one more that I don't remember off the top of my head. But there's also a bunch of other providers. Those are the major ones that I remember. So in order to add logging to your app, in order to add the logging and log provider, we have to actually add a package to the app. So that package is called I forgot to write it down. That package is Microsoft dot, where's my thing? Is it this one? Yep. I just got to find the right app here. So what happens when you have too many copies of Visual Studio open. It is called Microsoft dot, wait, do I got the right one? Yes. There's a couple different ways to do it. You can type it in this way if you're a glutton for punishment, or you can do in here Control-Shift-P and you get add package, and then type in Microsoft dot, and depending on the speed of the network, it kind of does IntelliSense for you, and it found it. So I do that. You get to choose the version. You can also just manually add it, but I'm going to do it that way since everything else failed. It doesn't actually get it until you click restore. Now it's going to go pull that package down, add it to my packages folder. And now I have the ability to log. You kind of have to configure what type of logging you want to enable in your application. Like I said, everything is an opt-in. So we are going to opt in by doing, let's see, right here. Let's do app dot, actually no, that's services. Services dot add console. Give it to me. Using Microsoft.extensions.logging. Once I do that, I should be able to get services.add_console. Am I typing services wrong? Nope. Is it app.add_console? Nope. Oh, silly. I have to go and add in logging here. And let's create a variable that I can use for logging. Actually, no, I don't have to do that. I can just go here and do services, add logging, and then I have the ability to add logging to it. And then in here, if I add the logger factory and do logger, I should be able to do logger.add console and then add debug. So it's a lot of extra steps, but again, like I was saying before, everything is an opt-in. This factory that you use could be any factory. The default one it comes with supports almost every logging framework that's out there, assuming the logging framework implements it. Once I do this, I have the ability to access logging anywhere, and I just do it through the dependency injection. So here, I'm going to create a public variable for logger, and logger, and then here I got to do the extension. This is one thing I don't like about Visual Studio Code. The IntelliSense part doesn't always work as smooth as it does inside of Visual Studio. So here, once I do that, I then can use dependency injection to do public home controller logger, let's call this underscore, and then I can set logger equal to logger. Sounds like I want a beer, which I really do right now. Now anywhere in my code, I can just call logger underscore logger dot log debug critical or error. So this allows us to just introduce any logger we want anywhere within our application. We can do it on a controller basis, views, anywhere within the code. It takes a couple of steps to set up, but once you get it set up, it's just as easy as doing these 3 lines. That being said, I believe that is the end of the demos. Thank God, I'm sweating up a storm. Last 2 slides, actually last slide, these are the ones that are supported or that have loggers put into it that are third party. Elma.io, Logger, Nlog, Serialog. I am 99.9% that Log4Net actually added one, but it's a separate community project, not based on the Apache project, because the Apache project pretty much killed Log4Net. There's also, Microsoft provides one for Application Insights if you want to do any logging to Application Insights. That's it from a very high-level overview of ASP.NET. If you have any questions at all, please feel free to reach out. Hopefully I can give you some bad code that won't compile in front of an audience, and you'll be set to go. It really does feel like the heat was turned up in this place, or the air conditioning was turned off. Your turn with the cable.
Thanks so much. You want to sneak out, or are you gonna?
No, get ready when you're done.
Go ahead and kill the stream, or I'll do the thing. So again, a big thanks to Joseph for speaking.